Hey guys, this is Mr. Lowry. Today in class, I passed out this kind of handout here. This is going to be part of your notes that's going to go in your notebook, and we're going to need it for next week. So the first part of class, this doesn't apply as much to like the homework that you're going to do tonight, but it's something that we kind of needed to get experience with for next week. So we kind of did double duty today. If you missed class today, this is day 3, which would be Wednesday the 17th for A day and Thursday the 18th for B day. You need to fill this out. Also, if you didn't finish this in class, then you need to fill this out. Okay, so let's go through this really quick. I'm just going to show you what to do. Okay, we've been talking about functions and relations this week, and we talked about different ways to represent a function. We know we can represent it with a table, kind of like we have here, with a graph, right? But we could also represent it with like an equation or a rule that gives us inputs and outputs. So this one, for example, whenever I input a number, I get that same number out. So for example, f of -2 is equal to -2, right? Like I replace the x with -2. Right? If I plug in a -1, I get out a -1. If I plug in a 0, I get out a 0. If I plug in a 1, I get out a 1. If I plug in a 2, I get out a 2. That's what this function does. You put the input here, and the input and the output match. So when you graph that guy, you have the point -2, -2. You have the point -1, -1. You have the point 0, 0. You have the point 1, 1. You have the point 2, 2. Now there's actually more points than just these 5. If we wanted to continue and like add some more inputs, we could get another point out here. So this actually keeps on going, but when you connect these guys, you get basically a linear function, okay? So this page is trying to give you some experience with lots of different types of functions, more functions than you've seen before. This one's a linear function, just a very basic linear function. But there's other kinds of functions in here that you maybe haven't seen before. This one we've talked a little bit about. This is a quadratic function. I'll show you what that looks like in a second. This is an absolute value function. And there's lots of different types of functions. In 9th grade, you learned a lot about linear functions and exponential functions. In 10th grade, we focus a lot on quadratic functions. But as your math career progresses, you're going to see lots of other types. So these are the basics. Now, sometimes these are called parent functions because they're the most basic version of that family. So this is the parent function for the linear family. There's lots of other types of linear functions, but this is like the most basic one, the one that has an intercept of 0 and a slope of 1. Okay. What I'm going to do here is I'm going to show you how you can use Desmos to help you figure out how these functions look. Okay, so I'm going to change over just really quick to a different screen. Okay, so hopefully you can see now what I'm doing over here in Desmos, and this is the paper that we were working on. Okay. So what we're going to do is we're just going to type in some of these functions. So let's do the second one here. That's right here. Okay, this is an absolute value function. So you can use y or f of x. It doesn't really matter. This one says f of x. Okay. Now on your keyboard, to do an absolute value, you need kind of a vertical line. So right under the backspace key, there's a key that will give you a vertical line. So if you hit shift and then hit the key that's right under backspace, you get a vertical line. It's kind of like a bracket basically. Okay, then we do X, and then we're going to close that bracket. So this is over here what the absolute value function looks like. Okay, kind of makes sense because if you put in a positive number, absolute value of a positive number is going to be a positive number. The absolute value of a negative number will be a positive number. Okay, so that's kind of what's going on here. Now you can practice with zooming in, zooming out, changing your settings. I usually like to get rid of the minor grid lines. It's a little cleaner that way. Okay, so that's what's going on there. So we can graph this now. So coming back over to my graph, I have these points 0, 0, and 1, 1, and 2, 2, and 3, 3, and so on. And I have these points negative 1, 1, and negative 2, 2, and negative 3, 3, kind of going this way, right? And another cool thing that you can do here in Desmos is you can come over to this gear and hit the gear, and then you can go over and you can hit this table, convert to table. And that will give you kind of input-output pairs, right? X and Y pairs that you can use to fill in the table over here as well. So an input of -2 gives you an output of 2. An input of 1 gives you an output of 1. An input of 0 gives you an output of 0. An input of 1 gives you output of 1, and so on. Okay. Now, you're not limited to those points. The reason why those points are so popular is because it's a few on the negative side, a few on the positive side, and then middle. But you can go over here on your table in Desmos, and you can actually add a point, and it'll give you an output, right? So we can put that there, or we could put in like a -3, right? And we can see what we're going to get out as well. You can also see that those points are kind of shown over here on your graph, which is kind of cool. So you can see what the coordinates are, which is really handy, powerful. Okay. The other thing that we want to do is we want to kind of find the domain and range of these. So let's add a little bit of information here. I know this box that we're using is a little small. Let me see if I can make it bigger for you. So we know that this is called the absolute value function. Okay. We also want to find the domain and range so that we know how this guy behaves. So for domain and range, we need to kind of find the boundaries, the farthest like left and the farthest right boundary. In this case, this line is going to keep going to the left forever and ever and ever. So the smallest possible input value we can pick, there actually is no limit. So I put -infinity. There's also not an upper end. There's not this line to the right is going to go to the right forever. So the biggest possible X I can pick, there's no limit there either. So my domain looks like this, -infinity to infinity, or sometimes we might write something like ARN for all real numbers. There's no limitations on that domain. Any X will work. You can take the absolute value of any real number. Okay, now for the range, we want to start with like the lowest value and go up to the highest. So this guy never gets below 0 because if you have a negative number, it just turns it positive. So 0 is the lowest I'm going to be able to go here. So my lowest value is 0, but I want to include that 0. And so I use this square bracket here that denotes include 0 in the domain. Sometimes we exclude things, and I'll show you one of those in a second. Okay, now my biggest possible value, so I'm never going to get below 0, but for y, but my biggest possible y value is infinity because these arrows are going to keep going up forever. Okay, so that's one way to write it, 0 to infinity. Another way you could write it is y is greater than or equal to 0. As long as y is greater than or equal to 0, that is a possible output, but we're never going to get anything negative. So on this worksheet, you want to go in, you want to graph the function, you want to fill up the table, you want to find the domain and range so that you're familiar with these functions for next week because we're going to be using them next week. Okay, let's take a look at another one of these and then I'll show you some more tricks and tips. So one of the weird ones, probably the hardest to find the domain and range, is this bottom left guy. Okay, so we're going to get rid of this, we're going to get rid of this. We're going to go back in and we're going to type the function. So f of x equals, and then we're going to do 1 over x. So I just use the slash key that's with the question mark. So right next to right under the question mark on your keyboard, there's a slash, and that will do a divide for you. Okay, so this is kind of a funky looking one, right? Kind of weird. Let's zoom out and see what it looks like. So this guy gets steeper and steeper and steeper and steeper, but never vertical. And this guy starts off really, really, really steep, but never vertical. And then it gets kind of more mellow as we go on. Okay, so I'm going to zoom in a little bit more so we can see. And you can use these to do that as well. I'm using the scroll button on my mouse, but you can use these keys as well, or these buttons. Okay. Now what I'm going to do is I'm going to create the table. So I'm going to go here, edit list. Boom. Let's move this out of the way a little bit so we can see our table. So this is kind of interesting. This uses decimals as well, which is kind of, we can use fractions or decimals. It doesn't really matter. But notice that 0 is undefined. That if I input 0, I get undefined. Okay, think about that for a second. If I put 0 in for x, I'm going to have 1 divided by 0. And we're not allowed to divide by 0. That gives us like an error. Okay, so 0 is not included in my domain. That's kind of interesting. Another thing is, let's think kind of about what this function is doing. So I'm going to show this on my paper really quick. Make that a little bit bigger. Okay, so let's find f of 2 for a second. Okay, f of 2 would be 1 over 2. So if I put in 2, I get out 1/2. On the table here, it shows 0.5, but same idea, right? This is called the reciprocal function because when you put in a whole number, you get a fraction. So input of 2 corresponds with an output of 1 over 2. If I put in input of 3, my output is 1 over 3. Okay, so every time as my numbers get bigger, my fractions get smaller. What if we put in a fraction? Okay, well, if I put in like a 1/2, then my function will do 1 over the input. So it's 1 over 1 over 2. In other words, 1 divided by 1 over 2. But we know that's the same as 1 times 2 over 1, right? Inverted multiply. So 1 over 1 over 2 is 2. So an input of 1/2 gives me an output of 2. So if I put in a fraction, let's take a look at this graph. If I put in a fraction, I get out a big whole number, right? If I put in a half, I get out 2. If I put in a third, I get out 3. If I put in a whole number, it turns into a fraction. So that's kind of what is going on with the shape. Same thing on this other side, on the negative side, but I can't use 0. Okay, so my graph here is going to look kind of like this. And then on the other side, it's going to look similar. So if I put in a -2, I get out -1/2. But if I put in a -1/2, I get out -2. Kind of something like that. Okay, and then I have this point right here. So kind of weird. Now let's add those to our table. Let's go here and put like 1/2 and see what happens. Right, put in 1/2, get out 2. What if I put in -1 over 3? I get out a -3. So these are more points that you can use, for your graph. So you'll see, like, if I put in that -1/3, that's like right here, I'm going to get out -3. So these points kind of show up on your table, which is kind of neat. So you can use that table to fill out the rest of your table, and you can add some points if you want to. But let's find the domain and range, which is going to be a little tricky. The reason why it's tricky is because there's a gap in your domain. There's a hole, right? We can't use 0. And so we have to do the domain a piece at a time. So let's look at just the left side for a second. Okay, what's the smallest x value you can use on the left-hand side? Well, this arrow keeps going off into -infinity. And so my domain for the left-hand side is going to be -infinity. And then I'm going to go all the way up. I can use all these numbers except 0. I can't use 0. So what I'm going to do is I'm going to put a 0 here, but I'm going to put a parenthesis around it that says, okay, you're going to go as close to 0 as possible. All these fractions, all these decimals are fine, just not 0 itself. So just to compare and contrast over here, bracket means include. Parenthesis means not included in the domain. Okay, you go as close as possible, like -0.00000001, but not 0 itself. Okay, that's the left side. Then we got to skip. We got to jump over to the right-hand side. Okay, I can use everything up to 0, just not 0 itself. So again, a 0 with a parenthesis that's saying 0 itself is out of bounds, but you can use like 0.0000001 or as close to 0 as possible. So that's my left end boundary. Is like 0, but not quite to 0. On the right hand side, this is going to keep going off to infinity. And so I got basically two pieces of the domain: negative infinity up to 0, skip 0, and then go from like just above 0 to infinity. And we usually tie these two pieces together with this symbol that looks kind of like a U. It's called the union symbol. Okay, so that's domain. Range is really similar for this one. So check out your lowest possible number. This arrow is going to go down for forever. So negative infinity is our lowest. And then you go up, work your way up, and you're like, oh, I can't actually ever use 0. Think about this for a second. There is no way to get an output of 0 here. You can't use 0 as an input, so you can't have 1 over 0. That's not equal to 0 anyway. But this top number is always going to be 1, regardless of what you put on the bottom. So your output will never be 0. And in your table over here, you'll notice at 0, the output is undefined. All right, so I'm going to put UND for undefined. So we can't get an output of 0. We can get as close as we possibly can to 0, but not 0 itself. Then we skip over to the other side of 0, so just above 0. And then we go off to infinity because this arrow goes up forever. Okay. So that's kind of the domain and range for this function. And once again, this is called the reciprocal function. Okay. Couple other tips and tricks for you. Some of these functions are hard to write. Like, how do you type this guy? Okay. So I'm going to show you that. And shout out to Vanessa from period 1 for helping me figure this out today. So I'm going to get rid of this guy, get rid of this guy, get rid of this guy. Okay, so I'm going to try to do this one right here, the cube root. So I'm going to write y equals, or x, f of x, whatever. And then I'm going to go down to this keyboard icon down here. Okay, the show keypad. Open it up, and it kind of gives you like this little calculator thing. Let's put this over here. Okay, so we're going to go to functions. And then we have all these different functions. And we want to go to MISC. Miscellaneous is what MISC stands for, miscellaneous functions. And you'll see, oh, okay, you got some other stuff, right? So we got like a root if we want to. Let's choose that. And now this will let us type a 3. So it's the third root. And then we'll arrow over and we'll put an X. Okay. And then we get this kind of funky S kind of shape. Again, the gear button, table button, and you got some values here. Now these are kind of ugly, right? So if you want to add some of your own, you can. Like, for example, 8 works out really nice. That doesn't fit on your graph as well, but you can kind of see some other values there. Okay, so that's kind of how you do the other ones. There's also a square root on here, so you can use that same tool, that same button I just showed you. There's also some shortcuts sometimes. So like, if you type in SQRT, it'll automatically give you a square root symbol. It'll turn into a square root. That's all I did was type SQRT. There we go. Square root X, there it is. Okay, again, gear and table. Okay, and you got some values here. Notice that negative values are undefined for this guy because you can't take the square root of a negative number. But you can take the square root of 4, and you can take the square root of 9. Those come out nice. You can also take the square root of 3, although that doesn't come out very nice. So you can kind of use this to get some values here, get your graph, and then you want to find the domain and range. Okay. One more thing I want to show you is just some other kind of fun things you can do just to see what any other function looks like. So let's do f of x again. And Desmos doesn't care whether you use function notation or not. You can use f of x or y. Equals. Okay, make sure you have the equals in there. You're going to get thrown off. Let's go back to those functions again, those kind of crazy functions. I'm going to hit function. And I'm just going to see what some of these other weird functions look like. So I'm gonna go to trig, and I'm gonna show you a couple trig functions. So we talked about SOHCAHTOA and stuff, and tangent, sine, and all that. So I'm gonna go to, sorry, this is kind of in the way. I'm gonna go to tangent, and then I'm gonna put tangent of x. Okay, so this is a trig function. Okay, it's not a trig. A trig ratio helps us find sides of a triangle, but you can actually graph a trig function, which you'll do in later math classes, and you get kind of these funky things, which are kind of pretty cool. So Desmos is kind of a fun thing to look and just see like what functions you can come up with, what functions you can see. There's tons and tons of different types of functions. We're just talking about kind of the basics, right? Basic functions. Let me show you another one that's kind of cool. Sine. So you can actually just type sine x as well. You don't have to like find that. There's the sine function. Looks kind of cool. Okay. One other thing that you can kind of do that's gonna lead into our lesson next week is you can transform functions. Okay. So let me show you what I mean by that. I'm gonna do my quadratic here. Okay, x squared. This is one of your functions here. So it looks like this shape is called the parabola. Okay, and we can get our table. Okay. But you can also you can mess with this function. You can transform it, what we say. So this is the parent function for this family, but you can mess with this parent function to get different types of quadratics. So let me put a 2 in front of it. Steeper, right? Let's put a 3 in front of it. Even steeper. What happens if you put a fraction in front of it? Wider. What if we subtracted a number from the end? Or, sorry. Okay, moves it down. What if we add a number to the end? Moves it up. So you can kind of practice or just play around with transforming functions. Transforming functions is taking the original parent function and doing something to it to change how it looks. You can multiply functions by stuff to make them different shapes. You can put a negative in front of them, right? That flips this guy around upside down, which is kind of cool. You can move them left or right. It's a little bit trickier. Okay, so that moves to the right. That's kind of weird. So this is kind of where we're headed next week. We're taking these basic functions, these parent functions, and we're going to transform them in a way that gives us new functions in that same family. Okay, so just a little crash course on Desmos. Get familiar with the basics here. Move this up so you can see it again. Get familiar with the basics, graph them out, see what they look like. Grab a table, figure out their domain and range. This is not your homework. Well, you're not going to turn this in. It's notes that you're going to need for next week. So if you don't have this by next week, you're going to be in trouble because you're not going to have the info that you need. Okay. I hope that helped with the basic functions and kind of gives you a taste of Desmos and what you can do in Desmos. And we'll be using this, like I said, next week. Okay. Thanks for watching, guys.